So we're going to be looking at a very tricky kind of question. It's an Olympiad mathematics. So follow me closely. You will gain a lot of value from this live stream. Now, this is the question we have. And to solve this, since we have same numbers, same powers on both sides, we are going to factorize. So if we want to factorize, we'll have 3 to the power of x, and this will be 1 plus 1 equal to 90. Why is it 1 plus 1? So that if you want to open the bracket again to get back this question, we say 3 to the power of x times 1 will give us the same thing. 3 to the power of x times this one will give us the same thing. That's what we just did. Now, 3 to the power of x, this will give us 2. Can you see what we're doing? Next, we're going to do is to divide both sides by 2. So we have 3 to the power of x to give us 45. Now, when you get to this part, the next thing you're going to think of doing is find the log of both sides. Get the log of both sides. So log 3 to the power of x plus log 45. Now, log 45, what will come to our mind is 9 times 5, sorry. So we have log 3 to the power of x equal to log 9 times 5. All right, so we proceed. Remember, there's a rule in logarithm that says the power can come back down here, like you can bring the power down to this part, they still mean the same thing. So we're going to apply that here, saying x log 3 equals log, and another rule again that says is almost similar with indices, law of indices. When you have multiplication, it changes to plus. When you have plus, it changes to multiplication, stuff like that. When you have division, changes to minus, minus changes to division, just like that. So here we're going to be applying the addition rule. So this will give us log 9 plus log 5. Plus log 5. So the next thing we'll do is to divide both sides by log 3. So we have x equals, so we split this each. We have this 9, we can regard it as 3 to the power of 2 all over log 3 plus log 5 all over log 3. Next thing we're going to do, the same thing we did here, we're going to apply it here as well. Bring down this 2 to the back, 2 log 3 over log 3, and this can cancel out, plus log 5 over log 3. And so our x, but that's not where we're going to stop. 2 plus log, since they are both on the same base, which is base 10, we are going to say log 5 to base 3. Are you getting it? So right here, this is the value for x. This is the value for x. So we want to check and see if what we did is correct using this question. So we have 3 to the power of x plus 3 to the power of x equals to 90. Now remember, our x value is the whole of this. So we're going to say 3, 2 plus log 5 base 3 plus, yes, 3, 2 plus log 5 base 3 equals to 90. Now, law of indices again. When it's plus, changes to times. So we have 3 to the power of 2 dot. Dots can be regarded as times, but we don't want to use times. So we can use dot. 3 again, log 5 to base 3. Why am I using both 3's? That's the rule. Since 3 is taking these two equations, 2 and log 5. So which means this same 3 is also carrying this one. Are you getting it? 3 is carrying 2 and 3 is also carrying log 5 to base 3. That's what it means. 3 is also carrying 2, still carrying this. That's what it means. So We do the same to the other one. Sorry. That's 3 to the power of 2 dot 3 log 5, 3 equal to 90. So now we're going to apply a particular rule in log that says a log b to base a is equal to b. So with this, we're going to apply it here. We're going to apply it right here. So 3 is representing a. You can see it here. So our final answer will be 5 here, just like that. So 3 to the power of 2 will give us a 9.5 plus 9 again, that's 5, equal to 90. So this will give us 45 plus 45 equal to 90. So we have 90 equal to 90. So this proves that what we did is correct.